Hello everyone. It's been a while since we opened this box, and a bit of a reflective time. Today we're going to do a few experiments, and we're going to give you a few thoughts on what's happened with our channel over the past month. As you can see, in the physical world we're still going. We've just been rather busy with our parallel projects. The ones that aren't as interesting as ChemPlayer, but they make us money. So today we're also experimenting with an investment in some new filming equipment. Let us know if it looks better. Okay, so our YouTube channel got killed. Screw YouTube. We're going to continue anyway. Okay, let's start with a dangerous sounding mixture. This is a combination of 70% nitric acid and 30% hydrogen peroxide solution. Unlike its piranha solution analog, it seems to be a much more stable combination. So let's try out the obvious. We'll add some copper metal foil and see what happens. It soon speeds up. Normally we'd be choking on brown nitrogen dioxide fumes, but here the NO2 is oxidized back to nitric acid. Only at the end do we start to see the brown gas coming off as the peroxide starts to be used up. Hydrogen peroxide is a very interesting oxidizing agent, and we wanted to have a play with it to see if it could be used successfully in some organic reactions. So let's try something out. One mechanism of action for hydrogen peroxide is via radicals. Hydrogen peroxide can split down the middle, forming two highly reactive hydroxy radicals. So here's some 30% strong hydrogen peroxide solution. And here's some iron 2 sulfate, which accelerates that radical formation. A lot of heat and oxygen generated, the hydrogen peroxide decomposes, and a red color due to the formation of iron 3 oxidation state results. So first let's try this oxidation mixture untamed and see what happens on a small scale. Here's an organic substrate. A little bit of cane sugar in a small beaker. Let's rock. No carbonization, but a strong aldehyde-like aroma in the air. Let's do another test, this time using benzyl alcohol as the substrate. It's always useful to see if an oxidizing agent has the potential to help us make benzaldehyde, a useful reagent in many reactions. Benzyl alcohol is immiscible with the hydrogen peroxide solution, as you can see. Okay, showtime. It broods away for a while. Some bubbles indicate a reaction occurring. And again, it kicks off and the room is filled with almond-scented benzaldehyde fumes. And a slightly burnt aroma too. Distract your dog now. It's got potential, but we're going to need to tame this. The delayed action suggests that we'll need to be careful with the temperature, and keep any reaction mixture well diluted. We'll try this on a small scale. Here's the setup for the reaction. We've got a 250 ml beaker equipped with strong magnetic stirring. Here's 5 grams of benzyl alcohol. And to dilute the mixture down, we're going to use 70 ml of water. We'll get this stirring vigorously. And we'll watch the temperature carefully using a thermometer. We'll also warm this mixture gently on the hot plate. Okay, let's have a chat. Back in 2017, YouTube tried some tricks after a few well-publicized issues with advertisers. Channels which were monetized for advertising got hit because YouTube became paranoid about some content being placed next to adverts. Great channels such as Explosions and Fire got hit bad, but apart from some age viewing restrictions, we seemed to sail through fine. Until February 2018. In early 2018, YouTube, faced with issues with per-click advertising revenue and infrastructure costs, changed a lot of rules around monetization on their platform. Under increasing political pressure, it also bumped up moderation of content, using outsourced third-party so-called trusted reviewers. Unfortunately, either deliberately or due to incompetence, they hired morons. One person's definition and personal perception of what content is acceptable is very different to another's. One person's definition of what they find offensive or politically correct can be radically different to someone else's. In the YouTube world, though, in terms of content involving politics, economics, social matters, and also content which morons find confusing such as science, the moderation has sunk to the lowest common denominator. YouTube in time will also sink to the lowest common denominator. So after receiving video strikes for urea peroxide, ghetto Grignard reactions, and making chocolate cake, we knew that sooner or later it would be over and with no way back. On April 26 our channel was deleted, and our Google account locked out. It's a setback, but in the end we enjoy making the videos, hopefully some select people enjoy watching them and learning something. We don't plan to make any money out of it, and we'll keep going anyway. No centralized platform increasingly having to pander to the mainstream and lowest common denominator is going to be different. So let's see how it goes. If we can all help to promote BitChute as an alternative, then perhaps we can drive more traffic here and turn it into a viable community. Okay, let's do this reaction. Here's a couple of grams of iron, 2 sulfate crystals. Slightly pink as they're old and somewhat oxidized. Temperature is at 45 degrees C, and this should be warm enough to facilitate the reaction and stop peroxide building up and posing a runaway risk. Here's the 30% hydrogen peroxide. A molar equivalent to the benzyl alcohol, so as to try to control any overoxidation. We'll add this slowly and watch the temperature carefully. Immediate change in color with every drop added. We kept the temperature under 60 degrees all the way and there has been no foaming at all, just a gradual darkening of color. The final reaction mixture is nearly black. We'll work this up with a solvent extraction and see what we've got. We add 25 ml of dichloromethane, which sinks to the bottom amidst a black gunky precipitate. Radical reactions are pretty uncontrolled, so we could have expected some black carbonaceous and polymeric material. Let's evaporate off the DCM and see what we've got here. We're left with a brown-looking oil, and a very strong sweet toasty artificial almond-like aroma. Not a lot of it though. We can do a little test by adding some saturated sodium bisulfite solution to the oil. With benzaldehyde, the bisulfite will react to form an insoluble adduct compound. As you will have seen on previous videos, this is often a good way to purify benzaldehyde. After a few minutes you can see a flaky insoluble solid substance starting to form. It takes a while, and some stirring for the reaction to occur. No awards for yields on this one, but it suggests that with the right conditions, hydrogen peroxide might be able to facilitate this reaction. Perhaps using a more dilute mixture, and using a smaller catalytic amount of the iron salt. Dilute hydrogen peroxide is readily available ODC, as are iron 2 salts, DCM, and sodium bisulfite. So we'll keep having a play to see if there's an ODC method to benzaldehyde here. In the meantime, keep in touch with us via our Twitter account, and here on BitChute. Thanks for watching. This show ain't over yet, so stay tuned.